and pull, right?
Yeah.
Okay. Does force make any deformation in shape or size?
Uh, no.
Are you sure?
Uh, yeah. So yeah, it does. Sometimes for some objects, force when you put its shape, sometimes changes.
Okay. So this is the basic definition. In physics, are you there?
Yes, I'm here.
Okay. In physics, there are few physical quantities. Are you aware of physical quantities? What is it? Can you name?
Scalar quantity and vector quantity.
A scalar quantity and vector quantity. You are really putting interest in my teaching style. I asked physical
Uh,
quantity. Physical, physical quantities,
yeah.
right?
Yeah.
Quantity. I written the singular, but it's plural. Physical quantities. Okay. You answer me. Vector and a scalar, right?
Yeah.
You said physical quantities. Number one is vector. Oh, good. And a scalar, right?
Yeah, sir.
Will you define vector and a scalar for me?
Vector quantity is when an object or is with only magnitude, has only magnitude, and scalar is when an object has both magnitude and direction.
Will you swap the definition?
So what's the definition?
Yeah, just swap the definition. What
Oh,
you
vector has both direction and magnitude, and scalar only has magnitude.
so update your information, okay? And add one more thing to vector is follow vector addition rule.
Okay.
So now tell me what is vector.
Vector quantity is when uh, object has both magnitude and direction, whereas scalar quantity is when an object has only magnitude.
Okay, that's your definition. But I am asking you to add one more thing to your knowledge about vector. That vector follow vector addition rule.
Mm.
Vector follows vector addition rule. I'm gonna tell you what is vector addition rule. So
Okay.
just you update your knowledge. Write down somewhere in your notes. Okay.
Yes,
Yeah.
sir.
Are you happy with these definition?
Yeah. Yeah.
Okay. So the point is now uh, you are aware of direction, magnitude, but you are not aware about the vector addition rule, right? Or you have
Yes, sir.
confusion in either of these things?
No, sir. Only this vector addition rule I haven't learned.
Okay. Do you know Pythagoras theorem?
Yes,
Perpendicular,
sir.
base, and hypotenuse.
Yes. Yeah.
Okay, you know. So
Yeah.
that's one of the thing that follow vector addition rule.
Okay.
So let me give you a little bit uh, explanation. Suppose suppose the this is your sorry, this is your right angle triangle. This is vector A, okay, and this is vector B, right? This is right angle triangle. This is the
Yeah.
simplest one. So this vector is in this direction, right? So this is
Yeah.
direction called I hat unit vector. Are you aware of it? No.
No. No.
So just keep it simple. Say it is an x-axis along the x-axis, right?
Yeah.
Vector B is along the x-axis, and this is vector A along the y-axis, right?
Yeah.
So its resultant will be given by the sum of vector A square plus vector B square, right?
Yeah.
This is the basic definition. Like two
Hmm.
forces acting on each other perpendicularly, then magnitude will be this.
Okay.
This is the vector addition rule. The Pythagoras triplet shows this. Okay. Are you there?
Sir, can you hear me? Sir, you're muted. I can't hear you.
Now I'm audible.
Yeah, now you're audible, sir.
Okay. So my question was, what are physical quantities? And you answered me a scalar and vector, right?
Yeah. Yeah.
So now you have updated your knowledge about vector,
Yeah.
okay, and a scalar as well.
Scalar, sir, is the same rule as the vector for the additional rule.
No, 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 that's not. The difference is only there. Okay.
Okay.
In a scalar, we can add like, for example, hmm, for a scalar, I'm writing here. This was the for vector. Okay. So for a scalar, we can only write 2 plus 3. This will be nothing but simply 5. Okay. we don't have to worry about the direction because a scalar has no direction, only magnitude, right?
Yeah.
So we don't have to worry about its direction. So there is no direction means there is no angle in between. Okay, this was angle 90 degree. That's the
Yeah.
Pythagoras triplet. So there is no direction. We have two vectors in some direction.
Okay, sir.
So you updated your knowledge.
Yes, I wrote it down.
Okay. So my question is still, what are the physical quantities?
Uh, Physical quantities is
What do you measure in physics? Basically, tell me. I'm making the question much simpler. What do you study in physics?
the about the motion of an object, the
So motion
it,
is one physical quantity,
the the direction of the
direction, of course, of course. The second
mm,
physical quantity,
uh,
velocity,
velocity and
displacement,
speed, uh, um, the distance, uh,
force,
mm, force, yeah.
what, yeah. Go on, add in the list. Work
Uh,
done,
what's up?
work done,
Work
work,
done.
yeah, work done.
Okay. Then
So these are physical quantities. Okay.
mhm.
So will you tell me what the difference between distance and displacement?
Distance is the path of the distance is the path length an object takes, and displacement is the shortest distance an object takes.
Displacement is the shortest distance between 2 points, right?
Hmm.
And displacement is,
The path length an object takes from 2 points.
okay. So how you will define the velocity and acceleration?
Velocity is velocity. We can define it as total displacement by the total time.
Of course, right. What about acceleration?
Acceleration.
Acceleration.
Uh,
Okay.
I,
Don't
I,
don't don't worry. Uh, so as you said that mm, displacement over time is your velocity.
yes, sir.
Okay, right? So
Yeah.
yeah. So acceleration is acceleration is velocity over time. Velocity over
Oh, time.
time, right? Velocity over time.
Yes.
So now tell me, velocity and acceleration is physical quantity or scalar quantity?
Well, could you repeat, sir?
Velocity and acceleration is velocity or a scalar, sorry, vector or a scalar quantity.
For both of them?
Both of them is a scalar, right?
No, I'm saying for scale velocity and acceleration.
Yeah.
Uh,
Is a scalar
velocity. Yeah,
quantity or vector quantity?
velocity is the uh,
Yeah,
vector quantity.
right. I won't confuse you much.
Okay. And acceleration is the scalar quantity.
Okay. How you think a scalar is a scalar quantity? Mind storming is important thing in science.
Uh,
Think, think for 1 minute. Good try. So tell me what is this quantity?
vector quantity.
Okay.
Hmm.
The what is this quantity? The time.
Uh,
We are not aware whether it's vector or a scalar.
yeah,
No, we time never follow the vector addition rule, so it's a scalar.
yeah.
Time has direction, magnitude, because time travels in one way. Time travels both way. It's also true. We can move to the past, okay, and we can move to the future as well. Time travel both ways, okay, but it never
Hmm.
follow any vector addition rule. So it's a scalar quantity. So
Okay.
you are dividing a vector by a scalar. So your acceleration remains as a scalar, sorry, vector.
Okay.
So got my point? So this
Yes,
is
sir.
your vector quantity. Got the point?
Yes, sir.
Uh, so now my point is again, what is work done? Have you read about work done?
No, sir.
Okay, so for time being, just see that work done. We define it like that. This, for example, this is not in the content context of our present teaching. Okay, so this is work done. This is force dotted with this displacement, right?
Yeah.
This is just for uh, understanding. Okay,
Okay.
so these two are force vector. This is also vector, but it
Hmm.
gives us a scalar. SCA, they are scalar, right?
Yeah.
Okay, with these discussion, we may move further, or you have any doubt? Vector and scalar concept is clear.
Yeah,
Uh,
that I understood.
that's totally clear. You are not stucking anywhere.
No, sir.
Okay, whenever you have any doubt during the lecture, you may ask the question.
Okay.
Okay, so we are clear with what are the vector and scalar. Okay,
Yes, sir.
what are the physical quantities?
Yeah.
Okay, so one of the physical quantities is force, right?
Yeah.
So is is understandable to you, or we are going little bit low or fast?
It's understandable, sir.
Okay, good. So will you tell me how many type of force exists in the nature?
Force, uh,
Yeah, say.
uh, types of forces. There's the gravitational force.
Yeah, good,
There is
good.
magnetic force.
Right, good, good, good. One is
eh, Gravitational force. um,
gravitational force, right?
yeah,
Right. What about the other one?
uh, magnet magnetic force.
Yeah, good, very good. Magnetic force, you played with magnet in your childhood, and still you may be playing with two
Yeah,
magnets, right?
yeah, yeah.
So the same phenomena you will find with when electric wire is wounded around a metal piece. Okay, so from there we get electricity and magnetism. So both force are combined together. You are right. Magnetic force is separate, or electric force is also separate. Okay, so
Okay.
they are unified, and we say that electromagnetic force, right?
Yeah.
Electromagnetic. Okay, okay, electromagnetic. What next? Do you have any idea?
What's up?
Any other force exist in the nature other than these two?
Um. mm, mm,
Have you heard about?
No, sir, I haven't heard.
You never heard about nuclear force?
No.
Okay. So this is task. When after the class, you Google it. Okay. Google it and
Okay.
find what is it. So Google it. Google it. Okay.
Mm.
They are more force as well, like frictional force,
Yeah. Oh, yeah. Frictional force is a. Um.
frictional force. Should I list adding on list, or we should move further?
You can add on, sir, because I know, so I can have an idea
Okay.
of forces are there.
Okay, that's good. So next is that's it. Frictional force or friction force. Okay. So gravitational force. Now tell me where you find gravitational force.
When we're walking, the gravitational force pulls us to the ground.
Okay. Where do you feel electromagnetic force?
Mm. When you put the magnet on the fridge,
That's good example.
uh, and frictional force is when you when you drive the car and you put the brakes, the friction helps it to stop.
When you walk, on the floor, is there any friction between we and the floor?
Yeah, there is.
Okay, that's why we can safely walk on the floor. Otherwise, we would have fallen.
Yeah,
Okay. What about nuclear force?
I don't know what nuclear force.
So basically, you have to Google it and make your short notes.
Okay.
Okay.
Hmm.
But so we discover almost type of force. One more is the weak force. That's totally different. Okay. So now we come back and define what is force in the sense of Newton. Can you define what is the Newton first law, Newton's laws of motion?
Um. Um. Uh. First law was every action has an equal reaction,
Oh, that's
opposite
good.
reaction.
That's good. That's good. That's Newton's law. I would like to write it down.
Okay.
You are really giving me very good interactive class.
Thank you, sir.
Okay. So you said about Newton's law. Newton's law. And that is every action has equal and opposite reaction.
Hmm.
So every action has or have equal and equal and opposite equal and opposite reaction.
Yes, sir.
Okay, good. Who is worried about which is the Newton first law, second law, third law? We have to study the law of nature. So
Ye-
for time being, just forget which one is first law and second law and third law.
Yes,
So
sir. That.
that's we have to study about the nature. So I'm writing it. If I apply a force on the wall, okay,
Hmm.
on the spring, so a spring also pulls us back.
Yeah, it pushes us back.
That's the opposite reaction, equal and
Ye-
opposite reaction. So
Yes.
this F force is force from you. Okay.
Hmm.
And this is force on you from a spring. You have
Okay.
pulsed a spring, right? So
Yeah.
so in magnitude, these two are equal, right?
Yes. Yeah.
But every reaction is equal and opposite. Every action has equal and opposite reaction.
Ye-
Equal and opposite. I missed to write here opposite. Opposite. Right?
Yes, sir.
So this is only showing the equal.
Hmm.
But the second part is missing. Opposite reaction. Now correct this equation.
Um,
Now
uh,
correct this equation according to your statement.
for the force of the spring, the arrow will point at Fu because it's giving the force back to us.
Good, very good. So we are pushing, you are pushing this with this force, right?
Yeah.
And this spring is pushing you back, right?
Yes, sir.
F of spring is pushing it back. So both have the different direction, opposite direction to each other, right?
Yeah.
It's going in this direction, this is going in this direction. So there must be a negative sign over here,
Okay.
right?
Yes, sir.
Okay. So from where you learned this definition?
Many my parents, teachers, friends all say these things because it's a common law. That's why.
That's the very well stated law. If you are
Yeah.
physicist or you are not physicist, but you always used to keep this law in your mind, right?
Yeah. Yeah.
So this is very famous Newton's third law.
Hmm.
Newton's third law,
Okay.
right? Action
Uh,
reaction. This is action reaction. So this is the third law, not the first law.
hmm.
Okay.
Okay.
So is there any confusion or any question regarding this law in your mind? You want to ask?
No, sir.
Then should I ask one question?
Okay, sir.
It's very general.
Okay.
Where we face this uh, law in our daily life? Do-
Um. Uh, uh, when you're jumping on a trampoline, when you jump up, the gravitational when you come down to the trampoline pushes you up.
right. So now I gonna give you one simple problem. The problem
Okay.
is the problem is simple. The simple as we think. Uh, this is the table where you are sitting. This is the table. Okay.
Hmm.
Here is your laptop or book, whatever it is.
Okay.
Right.
Yeah.
So this is your book. Right. This is not hospital bed. You cannot.
Yeah. It's fine, sir.
It's like so, nah? My drawing is not that much well. Okay.
No, sir, it's fine.
Okay. So here one force is acting on this book in downward direction. Downward direction toward the radius of Earth.
What, sir?
Okay. So you are back. So on this book is being pulled by Earth. Mass of where M is the mass of this book. Okay.
Okay.
And Earth is pulling it down. If you are sitting or chair will break, you will drop down. You will fall down.
Yeah.
Why? But the reason why not you fly up to stars? Why you fall down?
Because of the gravity.
That's the gravity Newton discovered, right? Why apple
Yeah.
falls down. Okay.
Yeah.
So this is the same amount of force acting on this book. Okay. This is the force, gravitational force. F gravitational. Okay.
Okay.
What about how it is balanced? Why it's not falling down to the ground? Reason?
Because it's on the table. The table is blocking it from coming down.
Yeah, table is also providing a force called normal force, normal reaction upside.
Yeah.
So see, this is the same. It's not falling. If books were heavy, suppose 10 quintal or 1000 kg, it must be broken down. The table will break down and this will fall down,
Hmm.
right? But
Yeah.
in this case, this normal reaction and this mg is balancing each other. It's in equilibrium. It's not in motion.
Hmm.
So
Okay.
this is a consequence of that definition.
Okay.
So this is opposite in direction or same in magnitude. So you may write
Uh,
it. You may write it n minus mg, or if I'll write the first law, mass time acceleration. This is acceleration. So it's not
yeah.
accelerating. It's not accelerating. So a is 0. So this term is 0 because a is 0, right?
So I'm confused on the n minus mg.
Yeah, I know. Because we directly jump to Newton's third law. So give me 1 second, okay? From this equation, this very equation,
Okay.
we are moving here. Can we write this n minus mg equal to 0? Just bring mg to one side, right?
It'll be, yeah.
No, no confusion now.
No, sir.
That's the one thing. So now we'll jump to Newton first law. You make the note, then we'll jump.
Okay. Sir, done.
Done.
Yes, sir.
Newton third law is okay. Clear?
Yes, sir.
Any doubt? Any confusion?
No.
Seriously?
Yes, sir.
Okay. So I'm putting you again in some uh, situation. Situation is that situation is I'm drawing this I'm drawing this line over here. Okay. We are going in new situation. Are you aware of this term?
Yes, sir.
What is it?
Tug of war.
What actually it means?
It's when two people are standing at each point and pull the rope at
Okay.
with equal force.
Okay. Equal force. If force is equal, the knot over here, this knot, if force is equal, this knot will fix at this point only, right? No one
Yes.
is winning, no one is losing.
Hmm.
But if suppose this guy is fat guy and this is thin guy, who will win?
The fat side.
The fat side. Means that now force is not equal, right?
Yeah.
Okay. So if force is equal, the particle will remain in its state of motion, either stationary or in motion. Okay. In
Okay.
absence of in absence of unbalanced force, the particle always remains in the state of rest or in the motion. If in the motion, if equal force act on the particle, it will remain in that uniform motion. Okay. If particle are at a stationary point,
What's that?
if particle is at rest and
Hmm.
force is balanced force, then it won't move.
Yeah.
That's the first law of motion. Not move
Okay.
means acceleration. In somehow, if the vector sum, you are well aware of vector. If the
Yes.
vector sum of forces, vector sum of forces is zero,
Hmm.
then acceleration will be zero.
Okay.
I think it's not okay from your facial expression.
No, because I'm hearing this for the first time. I'm understanding slowly by slowly.
So how you will define the first law of Newton?
Uh, when there's equal force, the point will not move. It'll stay at the same point, same like position.
That's
Uh,
that's what I have written. That's what I have written. Okay. So what is it? Suppose this is the point, right? One
hmm.
force F equal magnitude, one force F equal magnitude, one force F of equal magnitude, one force F of equal magnitude. Right?
uh, yeah,
That's all, right?
yeah.
So see how I'm gonna say what you said in some another word. This force and this force is in opposite direction with same magnitude.
Yeah.
So it's gonna cancel each other.
No, no,
If force is equal,
no, it won't cancel.
it will cancel. See, that's what the Newton's third law says.
The
This
it
this one,
is
this one. What is this one?
every
What is this one? This is
uh,
suppose this is 10 Newton in I direction. This is 10 Newton and this is also 10 Newton. So how much Newton it will be?
0.
That's why if two equal and opposite people come into war, there's no any, what can I say, distraction. When two equal people come in front of each other, the situation is calm. If one fat guy, one thin guy comes, then fat guy hit the thin guy and he dies. So
Yeah.
this was the meaning of Newton's third law. Okay,
Okay.
equal and opposite direction means that they cancel each other. The effect, overall effect is being cancelled.
Okay.
Now got the point?
Yes, sir.
It's okay. So this what you were saying.
Hmm.
This what you were saying. So these two will be cancelled out, right? Now agree?
Yes, sir.
If equal in and opposite in direction, that will be cancelled out.
Hmm.
Similarly, these two force will cancel each other. So what the next net force on this object F vector net is what? What the magnitude of F net?
Uh, uh, it's 0.
I won't confuse you. I will write simply what you said.
Okay.
Agree? So
Yes, sir.
what was your definition?
Uh, for the third law,
No, first law.
two equal forces.
Hmm.
When there's two equal forces pulling to one point, that same point will not move its position.
So if acceleration force is zero, so
Hmm.
force is zero, no force is acting. So particle won't move,
Yeah.
right? So
Will
particle
be-
won't move. It means that force is mass time acceleration. Okay, and that mass itself is constant. Mass is 5 kg, 4 kg, 3 kg for an object. So this is the constant. This is constant,
Yeah.
right? So this is
Yes.
constant. So if is zero, it implies that vector A is zero.
Yeah.
That's what you said,
Yes, sir.
right?
Yes, sir.
So it's clear.
Hmm. Yes.
I think first law is clear, right?
Hmm.
So we'll do second law in next session, right?
Okay.
So do you have any question regarding
No.
this? Why? If there is no question, it means either you understood everything or opposite.
I understood everything, sir.
Everything.
Yes, sir.
So can I ask some question
Okay, sir.
as a summary or conclusion?
Hmm.
Okay. So friction force. In regard to friction force, okay,
Hmm.
you just go and think which type of force acts in this case.
Sir, could you repeat?
Friction for the case of friction force,
Yeah.
which type of force is applicable? First law or third law?
Hmm. The third law?
Are you
Yeah.
sure? How? Define it. How and why?
Because like the spring example, the when I give uh, force to myself to stop, the friction pushes it back and makes me stop.
No. In spring motion, there is no such play of friction force. Okay,
Hmm. Okay.
because you push an spring. Okay, there is no contact with any friction. When you walk on the floor or when you roll on the floor, there is friction
Mm.
between you and the surface.
Yeah.
So if it's the very smooth surface, the tiles is nano tiles on the floor, and you are
Mm.
putting on a heel that has very less friction, then there will be less friction between you and the surface and you will slip,
Okay.
because less friction will not stop you your weight and you will fall down. That's why you might be seeing that some surfaces on the floor or on the stairs are make the lining over there to generate the friction.
Okay.
As the friction is strong, we will safe over there. Okay.
Okay.
Okay, so I think this in is okay for today.
Mm.
Okay, then see you. Bye.
Hello, sir.
Yeah,
So 1 second.
yeah,
Rebecca's mother. I just wanted to ask you is like, this subject physics for her is not one of her favorites, sir. So I wanted you to, I like the way how you're teaching her and you know the concept and the logic. I used to teach her, sir. So as towards the end, when you asked her the question, she gets confused like this. And this time her marks was quite less for physics, sir. So she's good in studies, but I'm not there with her all the time. But I could get it by your teaching that you know the in and out of it. So, sir, do you teach 10th also?
yeah. I'm teaching.
Okay. What is your name again?
Hamid.
Okay, Ahmed, sir. Okay, I just wanted to tell the person that you should only be with her. I don't want change of teachers. But sir, I just want her to like the subject also. She doesn't like physics a lot. So that's the main issue, I guess, with her. Other than that, she's good. So I want you to, and I know you will teach her well, but my main point is for the 10th, because without logic from 9th going to 10th, it will be difficult for me to, make her understand the concept. She's losing in very, like how you ask now the question, it's actually they ask for objectives for them, which action is used. And actually she knows it, but she just easily lose 10 to 12 marks like that only. What
Ah,
is it? Give reason question, right? What is that
Mm.
called? Give reason. Teacher gives three options, right?
Yeah, assertion,
Huh?
assertion question.
Assertion.
assertion.
Yeah, it's called assertion. Okay, fine. In our time,
Yeah,
it was something else.
yeah.
Yeah, so that's all. I wanted to have a word with you before you continue with her. I'll keep on a daily basis also. It doesn't matter. But yeah, sir. Yeah, the other point of speaking to is like 3 months. She has summer break now. So in
Okay,
this 3 months, she's quite relaxed, at least to focus with you. Once her school starts, she's a little bit busy, I know, because she's into many activities and stuff. But in this 3 months, sir, how much ever you can make her like and understand the concept, it will be very helpful. Yeah, that's all.
okay,
Rest,
okay.
yeah, you can do it your
So
way.
no, I have some question right to you.
Yes.
The one thing
Mhm.
is that uh, we experience science or arts or philosophy or psychology every day in our life. Okay,
Do I what?
in every day we experience science,
Yeah,
psychology, whatever the humanities and subjects other. We all
yeah,
we all feel and experience, but we
correct.
only appreciate those things which pleases us.
True.
Okay, so how you are gonna and she herself gonna make physics interesting so physics pleases her? That's the important thing.
Yeah. That is there.
Yeah.
That is there. Actually, to be frank, maths and physics was her favorite subject. But then when she starts learning for the exam in the physics, I can find that she's not loving it while learning. Like maths, she loves. She does the workout, no matter it's day or night. But when it's physics, she likes the teacher. She's understanding the concept, she says. But when it's before the exam, I find difficulty because the textbook I try to read and make her understand, it's a last minute of study, so I can't be fully with her all the time. And she's an independent child, but in the same time, a little bit of guidance if she gets, I know she can love it, because I used to love physics, and you will love it too.
Yeah, yeah, yeah. So will you tell me which is the standard book she follows?
NCERT
Yeah,
only.
NCR, yeah.
NCRT. So are you aware that NCRT class 10th has this force and Newton's law?
Yes, they do
Yeah,
have.
yeah, they do.
You have. So, can you share that book with that staff? So I'll see whether that is in class 10th NCRT or not. I'm a bit confused.
It's not available for us right now. I know my physics teacher teaches 10, so I know that she's following the same
No,
book.
he just wants to
But
see it if
the
it's
book
available.
I don't
Do
have
you
it
want
with
the
us.
grade 10 PDF, sir? Do you want it? I don't know if I can ask one of her teachers. I'm sure she'll share it to me. But right
Okay.
now with me, I have grade 9 because she's using it. But grade 10, you just want to know if this particular chapter is extended, right?
Yeah. So actually NCRT used to remove some chapters or something time to time. So I checked
Oh,
today NCRT book before coming to class. I didn't
oh.
find there's force and Newton's law of motion. So I was bit about to ask her as well.
Sir, because she's grade 9 now. You were asking 10th, right?
Right. So,
Yeah, she's grade 9 only, sir.
uh, uh,
She's not 10.
okay. Yeah, I got that.
Okay, so still you want to know grade 10 if they have? I can ask one of her teachers
No, no.
if it is
I
no.
was only having that doubt that
No,
that's
no, she's
not in
just
class
grade
10.
9. She
Okay.
hasn't gone to any tuition, sir. So you're the first tuition. I was a tuition teacher and she's a self-tuition. So this is the first time that I'm trying to, make her involved with a tuition. And
Mhm.
I can like the way how you're teaching because you're asking questions and stuff. So that's something nice. And Google the homework which he gave you. I didn't hear what was it.
Because
So
it's time. Okay. Because
yeah,
students are always with mobile phones. So
yeah.
so if you
Actually,
are
not that
if
much, but
but partially she must be using, not fully. I'm sure.
yeah, partially yes. Yes,
Yeah.
partially yes.
So it's one of the thing that we should attach every knowledge to ethics, etiquettes, ethics, manner, or some technology. So a student as well feel some enjoyment over there.
Yeah.
If
Sir,
I'll,
for grade 10, when you're teaching, sir, you usually have question paper patterns and all. Do you
of
already
course,
have?
of course, of course,
Oh, even for grade 9, will you be having, sir? Because again, I'm
everything.
telling, I'm good in teaching, but I'm not, I don't refer question papers. So when she gets some twisting question, that's where she, loses her marks. So I want her to think out of the box
Of course.
because you're not going to be a baby anymore. So now 9th and 10th, thankfully, we all scored marks those days. I don't know, the question was easy or probably, I don't know what was it. But nowadays, it's a bit tricky questions I can find, especially in one word questions. So,
Yeah,
so just yeah, as you said, how you're trying to explain to her what is velocity from the beginning. I think this is a good start for her to understand physics because the lowest mark she got in this term was only physics. The rest, yeah, it was like not because of anything else. She had dance and other stuff. She's a good girl, but yeah, she lost a bit. Yeah.
okay, my approach will be bit numerical based. Okay,
Yeah.
I love doing numericals.
Oh, that's
So
nice. That's
yeah,
nice.
we will try
That
to
is
provide
where
her
I
the
lost my
questions.
She
mark.
lost her whole marks in that only. Because sir, I couldn't make her practice in the last minute. Physics, you cannot do it in the last minute. You know how much it's like mugging up then. So I
Yeah,
didn't know, I thought she was understanding. Every day she comes back, she likes the teacher and she's enjoying. So I kept it. But towards the end, when I started asking her, I understood she's not knowing the logic much. Though she says she likes it. So that's the reason she lost. And I was surprised she lost on small, the question like how you asked now. It was
yeah.
easy to say it was Newton's first law. But
Mhm.
in her age, you need not easy. You need to think. I know, but for Mama, I just said, yeah. But
Yeah.
sir, just make her this 3 months. I'm just leaving my child to you, and later also I will leave her to you. Internet connection. There is sometime a problem. Sir, from which place are you connecting in India? From where are you from?
Delhi.
You're basically from Delhi only. Okay,
Yeah, yeah.
I hope this connection issue might not. So she will be a child till grade 10, sir.
Thank you, thank you,
No, I liked it. First time yeah.
thank you
I
for
like,
trusting on me.
yeah. So now here you go. You may say
So
bye to sir.
my last request or remark for you is that try to
Yeah.
read NCRT line by line.
Okay.
Okay,
Okay.
line by line. And I'm sure that each line of NCRT is like knowledge filled with what can I say? This one line contains the knowledge about all the physics. You can't skip a single line.
Hmm.
So if you are able to understand each and